So we're given the polynomial x cubed minus 4x squared minus 6x plus 12, and we're asked to express it as the product of linear factors given that -2 is a 0. So by the linear factor theorem, we know since this is a cubic, we should be able to write the polynomial like this in factored form, where each of these factors is a linear factor, hence writing it as the product of linear factors. So since -2 is a 0, we know that x equals -2 is a 0, and I want to rewrite that as a root. So I just need it to be equal to 0 again. So I'll add 2 to both sides, so I get x plus 2 equals 0. So I turned the 0 into a factor. So I know that one of these factors is x plus 2. Now I just need to work on finding the other two factors. Well, since I know that x plus 2 is a factor, then if I divide this polynomial by x plus 2, it'll give me the other, whatever's remaining from the polynomial. Just like if, let me do a side note real quick. Let's say I have the number 16, and I know that 2 is a factor. We know that, right? So that means that I can rewrite 16 as 2 times some other number. Well, since you know your multiplication tables, you probably know that that missing number is 8. But another way that we could find it is by dividing 16 by 2. 2 goes into 16, we know that 8 times, so hence we found that missing factor. We do the same exact thing with polynomials. So I'm going to divide this polynomial by the factor x plus 2. In dividing x cubed by x, I'll end up with x squared, so I'm going to get a quadratic that I'll then just need to solve either by factoring or quadratic formula to find what the other zeros are, so I can find what the other factors are. So I'm going to set this up. I'll do it long division, since Alex asks for long division. But if you prefer, and you know how to use synthetic division, since we're dividing by something linear, you could use synthetic division. Ooh. Okay. So x goes into x cubed. I'm going to need x squared. So x squared times x gives me x cubed. X squared times 2 gives me positive 2x squared. And now I need to subtract. -4 minus 2 gives me -6x squared. And x cubed minus x cubed cancels out. Bring down my next terms, -6x. So what do I multiply x by? That gives me -6x squared. And the answer is -6x. So -6x times x gives me -6x squared. -6x times 2 gives me -12x. And again, I need to subtract. -6 minus -6x squared cancels. -6x minus -12x. Be careful with your negatives. It can be tricky. A negative and a negative make a positive. So -6x plus 12x gives me positive 6x. And bring down the 12. And last time, I need to multiply 6 times x to get 6x. So I have a plus 6 here. So 6 times x is 6x. 6 times 2 is 12. And subtract. 6x minus 6x cancels, 12 minus 12 cancels, leaving me with 0. You should end up with 0 since we know that x plus 2 is a factor. So I should have a remainder of 0. So what that tells me is x plus 2 times x squared minus 6x plus 6 gives me that original polynomial back. But we're asked for it as a product of linear factors, so I need to factor or solve the x squared minus 6x plus 6 so I can write it in that factored form. So looking at this quadratic, is it factorable? The factors of 6 are 1, 6, 2, and 3. None of those will combine together to give me -6. So it's not factorable, but I can just go ahead and do the quadratic formula. So let's skip over real quick and do the quadratic formula. So I'm going to rewrite. I have x squared minus 6x plus 6. And I want to perform the quadratic formula. So I get x equals negative b, so I have 6 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which gives me 2. So I have x equals 6 plus or minus the square root of negative 4 times 1 is negative 4, times 6 is negative 24. So I have 36 minus 24, which is 12, all over 2. And now I want to simplify this. I need to simplify the square root. Notice I have 1, 2, 3 terms. And the only way I can simplify it is if all 3 of them are divisible by the same number. If a number is underneath the square root, I can't just simplify it. I need it outside the square root. So I know that 12 is 2 times 2 times 3. So that means I have a pair of 2's that can come out and a 3 that stays in. So it simplifies like this. And now all 3 terms are divisible by 2. So I can rewrite this as x equals 3 plus the square root of 3. Now we have the zeros, so just like we rewrote negative 2 back as a root, we need to do the same thing with these zeros. So we come off to the side. I have, just get another piece of paper. I have x equals 3 plus the square root of 3. And we have x equals 3 minus the square root of 3, right? That's what the plus minus means. I can break it into 2 individual zeros. And now I want to rewrite them as factors. So to rewrite them as factors, all I need is it to be equal to 0 again. So everything else needs to be moved over. So I'll subtract 3 from both sides. And then I'll subtract the square root of 3 from both sides. And ta-da, there is my factors. So I know in one of these little holes, I need to write x minus 3 minus the square root of 3. And now I'll just do the same thing with the other 0. I need to rewrite it as a factor, which just means I need it to equal 0 again. So I'm going to subtract 3 from both sides. And now this time I'll add the square root of 3 to both sides. And there we go, it's equal to 0, so I have my factor. So in the last little hole, I have x minus 3 plus the square root of 3. And there is my polynomial written as the product of linear factors.